So now we look at the history of computers after World War II or during World War II. And we'll see that some huge advances in our understanding of the capacities of computers helped show to humanity that computers could actually be useful. And suddenly they started being used in all kinds of different applications. So unfortunately, the ignition came from the war. And actually, there were two purposes for using computers during the war. So the first one is breaking German communications. So this was first done by Poles, so people in Poland, and they were doing cryptanalysis of German communication, and then later it was done by people at Bletchley Park in the UK, people such as Alan Turing. So let me explain how this worked. So this is all related to the German Enigma machine. This Enigma machine, and you can see a picture here, is composed, it's essentially like a typewriter, but more complicated. So the typewriter has keys here and wheels here. And the idea is that when you want to type a message, you set up the wheels in some position and you keep that a secret. And you type on the keys of the typewriter. And instead of pressing A and A being written on some piece of paper, well, what happens is that an electric signal goes from the key press of A through the wheels many times over, and the wheels allow to swap electric signals many times over, and in the end it's not A that's printed, but it's maybe W. And once that happens, the settings of the wheel changes. So the wheels move a little bit. And each time the settings of the wheel changes, it changes the path that the key presses follow. So you press A and then you get W, but if you press A again, you'll get a different letter because the settings of the wheels have changed, and so on and so on. So basically what you get on your piece of paper is a bunch of garbage, or at least what looks like garbage. You get a bunch of random letters, or seemingly random letters. You send that over the radio, and the Allies might be intercepting your communications, and then it goes to headquarters, and in headquarters they have the exact same machine. Now, if you just have the machine, it's not very useful because you don't know what the settings were. But if you have agreed beforehand on some settings, you put them, and then you start typing. And the machine is designed so that when you press W, you get A. You see? So originally you go from the plain text to the ciphered text, but if you type the ciphered text, you go back to the plain text, provided you have the settings. So the main idea for using computers is that basically what Turing and the others did was simulate this. They were simulating, again, it's the same idea, simulating many different settings, many different machines. And for this, the bomb machine was invented, and the bomb was essentially a bunch of Enigma computers. And later on, the Colossus machine was invented, and it was again the same process. It was generalized, so the bomb could only simulate Enigma machines. It was, if you want, a meta-Enigma machine. It consisted of many wheels that tried many settings, and every day would try to break the code for the day. But the Colossus was even better. What happened is that the Allies realized, wait a minute, the Germans have the Enigma machine, but then they have other encryption mechanisms. Why don't we just design a machine that's made to crack every single one of the German machines? That's essentially the idea. Progressively, they built more and more advanced machines, and they arrived to the Colossus that actually happened more or less at the end of the war, and was the first true computer that was built. So it had the full power of a computer of today. It was just much, much slower. Now, I've also put here a punch card. So a punch card is an important object. It didn't quite look like this in the 1940s, but this is a punch card from a bit later. For a long time, interaction with the computer, so human-computer interaction, was done via punch cards, and also interaction between computers or for the computer with itself. So the punch cards were used sort of like a memory, and the humans could also punch the cards themselves, so they could affect directly the computer's memory. So it's, if you think back of the abacus, it's a pretty similar idea. You have a card and you punch a hole or not, and each hole that is punched means some number or some setting, and you can just pass those around and manipulate them. And that was the main idea of the punch cards. Okay, so this was the first application of computers during the war. The second one is also not very peaceful. The second application is the atomic bomb. So for doing the development of the atomic bomb, the US set up a research center in Los Alamos in the desert, and this was called the Manhattan Project. A lot of very famous scientists worked on this. For instance, von Neumann, Feynman, Metropolis. So some that were famous already at the time and some that became famous later, like Feynman. So Feynman's a very interesting character. If you ever have a chance, you should read his biography. So you have pictures of them there. What happened is that von Neumann was building a computer or something like an electromechanical Pascaline, something like that, on the East Coast. And Feynman and Metropolis wanted to perform computations for simulations of what would happen when an atomic bomb explodes. And Feynman was, in particular, directing a group of people that were doing those calculations with all calculators. So they had calculators and lots of people. And some primitive form of program that were written for those people, meaning some person was doing all day. So they had the calculation to do, and they were using those mechanical calculators to do those calculations. Now, the first step of Feynman's reasoning was to realize, wait, we can reorganize those calculations differently. And we can tell one person to start computing square roots all day and trade them to do that. And then we take some sheet of paper and we put on it a number for which we want to compute the square root, and that person would do it. And as part of the instruction, there would be the instruction to pass the result to some other person in the room. And actually, a lot of those people were women because they were contributing to the war work without being at the front. And so those women were passing around all this data and all these numbers written on sheets of paper. And Feynman first optimized their calculations in this way. He describes that in his autobiography. But then came the realization that you could actually do all this with the computer, with von Neumann's computer. And this was the next step, which was to replace some of the calculations themselves, like computing the square root, with a computer, and then some of the passing around of information also with the computer. And Feynman, still in his autobiography, describes that moment where the humans, the human calculators, were replaced by a computer, and how the computer was quite slow at first, and the humans and the computer could actually compete. They could try to perform a huge, complicated calculation at the same time and figure out who would win. And this would take months, actually. This would really take months on the machines and for the humans to do. But for a while, the humans could compete, and then, of course, some improvements in technology meant that very quickly the computer won that race. And of course, by now, computers are billions of times faster than us. Okay, so many things happened here. And the main thing that happened was the abstraction, going from calculators to computers. And some other steps that are interrelated happened as well. So we went from analog objects, analog machines, to digital machines. So the positions that those objects could be in was discretized. That was an important step because it meant errors were less frequent and could be corrected more easily. It meant a whole less complication in building those actual machines. Also, some of the machines were electromechanical, but this became very quickly electronic. So electronic machines were faster and more reliable, so they eventually won over. But the main step, the most important step, was that we went from calculators that were single purpose to actual programmable computers. So machines that could be used for more than one thing. You could use the Colossus to break Enigma communications, or you could use something like Colossus to break Enigma communications, or some other ciphers that the Germans were using. You could use von Neumann's computer to perform computations related to the atomic bomb, or some other computation in a different field. Okay, but it's important to understand that there were a few required leaps in order to be able to go from single purpose to programmable, and this was a leap from analog world to digital world, electromechanical to electronic. And in addition, there was a lot of motivation needed and funding needed. because Babbage had some of those ideas already, but people didn't realize the interest. The interest came with the war. Obviously, the Allies wanted to win the war. So suddenly they managed to put in a lot of money, and they managed to put in a lot of manpower or women power into this. And actually having humans was very helpful, because when you're building a machine and the machine does not work quite as you want, you can always tell a human to do this part of the job instead of the machine. So it helps build a partial machines, if you want, that progressively becomes better and better. Okay, now after the war, what happened? Well, in the hardware, there was a lot of evolution, but it's mostly incremental, meaning nothing really changing the world anymore. It's just making it faster and faster. So we went from vacuum tubes to transistors and to semiconductors. So this helped reduce the size of computers, which means, for instance, that you can now have in your pocket something that's tremendously more powerful than whatever the astronauts on Apollo 11 had in their capsule. They had a computer, but it was very big for the number of computations it could perform per second. Your iPhone is much more powerful than those machines. The input also changed. We're used now to inputting things via keyboards. At the time, it was via punch cards. And we can see that in the future, the interaction with computers will also change. We have touch screens now, Google Glasses coming out. We suddenly have a lot of other ways to interact with computers, like Kinect and things like this. Finally, the persistent storage also changed. So persistent storage is the storage that stays even though you've turned off the computer. So if you turn off your computer and start it again, you still hopefully have your files there, your letters, your whatever in your computer. So before, this was done via magnetic tapes or sometimes with punch cards also. At the time it was done with punch cards. Now it's done with hard drives. And if you have a lot of stuff to remember or stuff to store, use magnetic tapes. Okay, but this is evolution in hardware, and as I said, it's incremental. But the current computers essentially have the same capacities as computers of around 1950. They're what's called Turing complete, and we'll see what that really means in an extra in the course. But the difference is that they do all this at a different scale of speed, of storage, etc. They can store a lot more data, they can process it much faster. That's the difference so far, because some people think that a revolution is going to happen, and that revolution is called quantum computing. So I'm not qualified to explain it, but there is a lot of hype around it, and people think this will be a fundamentally new model of computing, a fundamentally new way of doing computation. Now, the interesting thing that happened since the 1950s is in the software. So the software has evolved a lot, and the point of software, the point of the programs, is to help us leverage the capacities of a hardware, of a computer, more easily and efficiently. And actually, there was a lot of evolution, a lot more software was written, and it builds on previous software. But we're still sort of figuring that part out. So there is a lot of different operating systems. There is not one that is much better than the others. There's a lot of different programming languages, lots of different ways of using the computer. And actually, for every application, for every range of application, there's probably a programming language that is designed specifically for it, that makes it easier. And so there is a lot of interesting things with the software that happened since the 1950s. A lot of new concepts emerged, and I hope to show you some of those in the course.